Today we're going to be talking about factoring trinomials. And trinomials are polynomials with at least 3 terms. And in particular, for factoring trinomials, there's going to be 2 different methods based on whether or not your trinomial takes the basic form x squared plus bx plus c versus ax squared plus bx plus c. Essentially, if the leading coefficient to the trinomial is 1, if it's just a plain x squared, this is going to have a potentially shorter method that you can use, versus if that leading coefficient is anything other than 1, then you're going to have to use factoring by grouping. Just at least as a quick preview. And when you're factoring, what you're doing is you're basically undoing foiling. So you're undoing distribution. So you could always double check your work by redoing the foiling. But let's go ahead and go over that first case where that leading coefficient is 1. So your goal when the leading coefficient is 1, let's say you're dealing with something like x squared plus 7x plus 12, is to find 2 numbers such that they multiply to c, which in this case is 12, and they are going to add to b, which in this case is 7. And why is that? Well, if you are dealing with, let's say, x squared plus 7x plus 12, those numbers that you would come up with would be that 4 times 3 gives us 12, and 4 plus 3 gives us 7. Just going to highlight these in different colors so you can visualize where each number came from. So that's why we would then factor this into parentheses x plus 4 times parentheses x plus 3. And when we factor it, we haven't actually changed the value of the problem. If I were to refoil that out, x times x gives us x squared. X times 3 gives us 3x. 4 times x gets us 4x. 4 times 3 gets us 12. So let's just kind of note what we just did with that foiling there. At the end of the day, because that leading coefficient was 1, we effectively ended up adding 4 plus 3 here in the center to re-get us 7x. That's where that part came from. Versus we ended up multiplying, whenever we did the last terms, the 4 times 3 to get us 12. So that ended up giving us the plus 12 part, and then the x squared part just stayed the same no matter what. Because that worked out exactly that way, you can already envision that if I needed x squared to have some sort of leading coefficient other than 1, then when I did that first term times the last term, or if I did the middle terms times each other, I'm going to end up with something different than just 4 plus 3 here in the center. We'll see that a little bit more in depth here later, but let's go over still how to just factor these simpler cases a little bit more. So you need to note what is considered C and what is considered B, and you want to multiply to C and you want to add to B. So in this next case, it's pretty similar. Our C is actually still positive 12, but our B this time is negative 7. So what's going to multiply to positive 12 but add to negative 7? That's going to be x minus 4, x minus 3. And similarly, if I were to refoil this out, then I would end up with x times x is x squared, x times negative 3 is minus 3x, negative 4 times x is negative 4x, negative 4 times negative 3 is positive 12, to indeed get us x squared minus 7x plus 12. So I know I did it correctly, and my final answer is indeed parentheses x minus 4 times parentheses x minus 3. Let's go ahead and go over this last one. So I'm going to encourage you to go ahead and pause your video and try this last one yourself, and then we'll go through it together. So for this last one, you again want to note C and you want to note B. In this case, C is negative 5, B is negative 4, and the numbers that would multiply to negative 5 but add to negative 4 would be negative 5 and positive 1. And again, you can also check your work. If I did x times x, that's going to give us x squared. X times 1 will give us 1x. Negative 5 times x gets us minus 5x. Negative 5 times 1 gets us negative 5, to end up with x squared plus negative 4x minus 5. And now I also made a very rookie move in terms of those variables, because what were those variables? They weren't x's, they were a's. So make sure you're actually using the same variable, because my original was a squared minus 4a minus 5, not a bunch of x's. So do keep that in mind. However, if the leading coefficient is not 1, you can't just jump to that. Instead, you're going to want to follow a different set of steps. So here, instead of just having a b and a c, we're also going to have a non-trivial a. And our first step would be that if there was a greatest common factor between all three terms, factor that out. There's not, so we're going to keep on going. So we want to find with the remaining term, which is this, that we want to find what's going to multiply to a times c but add to b. So that's what it means by in the remaining terms with the GCF factor out, multiply the coefficients of the first and last terms. So the first and last terms, that's a times c. So in this case, a times c is 4 times 3, which is going to give us 12. And b, in this case, is 7. So what's going to multiply to 12 by add to 7? Those will still be the same numbers that we found before, which is 4 and 3. What we're not going to do, though, is just write down x plus 4, x plus 3. That was the answer to our first problem here, and we already know that doesn't FOIL out to 4x squared plus 7x plus 3. What we're going to have to do instead is I'm going to go ahead and rewrite this. We've got 4x squared plus 7x plus 3. We're going to have to rewrite the middle term as those two numbers I just came up with. So the 4x plus 3x. And then I'm going to drop down the rest of this. And I'm actually just going to rewrite this in a little bit more of a neat way. Sorry for that abrupt cut. I am not actually an influencer. I just wanted to make sure that I had enough room to write here. So let's keep going here. So we've done the first step of factor out the GCF if possible. We found out what's going to what a times c is. We're going to find two integers, 4 and 3, such that their product is a, c, sum is b. And then we're going to rewrite the middle term in terms of those two numbers. And now we're going to factor by grouping from here. So that's why we spent so much time factoring by grouping. So for factoring by grouping, in these first two terms, their greatest common factor is 4x. And what would be left? Well, 4x squared divided by 4x is going to leave us with x. 4x divided by 4x is going to leave us with 1. And then between 3x and 3, their greatest common factor is 3. 3x squared divided by 3 is x. 3 divided by 3 is 1. And then lo and behold, these now have a greatest common factor of x plus 1. So I'm going to wind up with x plus 1 times, and what they have different, 4x times x plus 1 divided by x plus 1 will leave us with 4x. 3 times x plus 1 divided by x plus 1 will leave us with 3. And if this is looking unfamiliar, I'd encourage you to watch the video I have on factoring by grouping. So those are your basic steps. And then again, this is rewritten a little bit more neatly here. If you like the nice typed out solutions of if, for example, we had 6x squared plus 11x plus 3, a times c would be 6 times 3, which is 18. B is 11. 9 and 2 are going to be your numbers that multiply to 18 but add to 11. So we're going to first rewrite that middle term as those two numbers we just came up with. Then we're going to group our two terms. Then you're going to pull out the greatest common factor of each group. When you've done that, they have 2x plus 3 in common for our final factorization of 3x plus 1 times 2x plus 3. So I'm going to encourage you to pause your video and try these next to yourself. And my hint to you for the last one is there should be a greatest common factor you pull out first. So for these next two, for this first one, we're going to find that a times c is going to get us, in this case, 12 again. I promise it does not always work out to 12, but this did this time. And then b is going to be 8. So what's going to multiply to 12 but add to 8? That would be 6 and 2. So I'm going to split the middle term into 6y plus 2y. And then I'm just going to drop down our other terms. Now I need to make my two groups. In my first group, what's their greatest common factor? 2y. 4y squared divided by 2y gets us 2y. 6y divided by 2y gets us 3. In our second group, if we don't notice the greatest common factor, well, the greatest common factor of anything prime is just going to be 1. And then both of those terms divided by 1 will still leave you with itself. They now have 2y plus 3 in common. So we'd have 2y plus 3 times 2y plus 1. And whenever you do this, you can always check your work, which I would still encourage you to do. So how would I check my work here? Well, I would go ahead and multiply it out. So 2y times 2y is going to get us 4y squared. So far we're in business. 2y times 1 gets us plus 2y. 3 times 2y gets us plus 6y. 3 times 1 gets us plus 3, and that does indeed simplify down to 4y squared plus 8y plus 3. So we know we're in business. And I'm just going to highlight that this was actually our final solution. We were just checking down here. For the next one, I hope that you factored out a greatest common factor first, which in this case was 5. 10p squared divided by 5 is going to leave us with 2p squared. Negative 55p squared divided by 5 will leave us with negative 11p. 7d divided by 5 is going to leave us with, I am blanking, that would be 12. No, it's not 12. I'm a liar. It's 14, right? Let's actually just do that to the side. 5 goes into 7 one time. 7 minus 5 is 2. Drop down the 0. 5 goes into 24 times. So yes, it's 14. We're good to go. Now, in the remaining term, we again want to ask ourselves the same question. So what's going to multiply to a times c, which in this case is 2 times 14, which is 28, and add to b, which in this case is negative 11. That's going to be negative 4 and negative 7. That's going to multiply 28, add to negative 11. And I'm just going to drop down all of our other terms. Now that we've dropped down all of our other terms, we're going to want to keep going. So we're going to kind of just ignore the 5 chilling out front. We're just going to focus on what's left here in parentheses. So in particular, the greatest common factor between 2p squared and 4p is 2p. What's going to be left in parentheses? Well, 2p squared divided by 2p is going to leave us with p. Negative 4p divided by 2p is going to be negative 2. For our next two terms, negative 7p plus 14, well, there's a leading negative, so I at least want to pull out a negative, and 7 and 14 have a greatest common factor of 7. Negative 7p divided by negative 7 is going to leave us with positive p. Positive 14 divided by negative 7 will leave us with negative 2. And then we still have the 5 chilling out front. And then we want to keep going for our last step. So we still have the 5, and then these have p minus 2 in common, so that would be 1 parentheses. And then 2p times p minus 2 divided by p minus 2 leaves us with 2p. Negative 7 times p minus 2 divided by p minus 2 leaves us with negative 7. Or you can remember 1 parenthesis of what's the same and 1 parenthesis of what's different. And then we're good to go. That's our final factorization, and I would encourage you to try to FOIL that out yourself. You should get back to the original. So I'm going to encourage you to try to pause your video again and try these next 3 and then compare with what I get. So for these next ones, we're again going to want to note what is a times c. In this case it is 20. What is b? In this case it is 12. What's going to multiply 20 and add to 12? That would be 10 and 2. I also should have technically checked that there was nothing that went to all 3 terms, but I already noticed the first term was 5 and the other ones are definitely not divisible by 5, so we're good to go. So I'm going to go ahead and split up that middle term into 10x plus 2x, and then I'm going to drop down everything else. Now I want to go ahead and do the by grouping part. So in this first group, what's their greatest common factor? 5x. What's going to be left? Well, 5x squared divided by 5x is going to leave us with x. 10x divided by 5x is going to leave us with 2. In this next group, what's their greatest common factor? That's going to be 2. 2x divided by 2 is going to leave us with x. 4 divided by 2 will leave us with 2. And we are good to go. We're going to have 1 parenthesis of what's the same, which is x plus 2. and another parenthesis of what's different, which in this case is 5x plus 2. And indeed, if I were to refoil that out, I should get us back to the original. Next problem, same deal. I want to check, is there something that goes into all three terms? There is not, so I'm going to go ahead and continue. In this case, a times c is going to be negative 60. B is going to be 11, so I want to come up with something that multiplies to a negative 60 and adds to 11. In this case, I believe that will be positive 15 and negative 4. If that wasn't coming to you, I'd encourage you just to kind of start listing out the factors of negative 60 until something works. So we're going to have positive 15x minus 4x, and then we're going to drop down our other terms, 10x squared minus 6. And you might be wondering, how do I make this order? It doesn't actually matter what order you write the numbers in. It will actually work either way, as long as you have a positive 15x and a negative 4x somewhere. So I could have written negative 4x plus 15x or 15x minus 4x. It's still going to work. So for those first two terms, 10x squared and 15x, their greatest common factor is 5x. 10x squared divided by 5x is going to leave us with 2x. 15x divided by 5x will leave us with plus 3. For the next two terms, there's a leading negative, so I want to definitely factor out a negative. And between negative 4 and negative 6, specifically negative 2 will be their greatest common factor. Negative 4x divided by negative 2 will leave us with 2x. Negative 6 divided by 2 leaves us with plus 3. And now they have one parenthesis of what's the same, which is 2x plus 3. And what will be remaining after you divide out that parenthesis from both terms will be this 5x minus 2. And again, if you were to refoil it out, you would find that it works. For this next one, be nice to yourself. If there's a greatest common factor between all three terms, pull that out, which in this case is going to be 4. 16x squared divided by 4 will leave us with 4x squared. Negative 32x divided by 4 will leave us with minus 8x. 12 divided by 4 will leave us with plus 3. And now we want to factor this remaining term. And actually, I believe that remaining term we had almost previously factored before. I'm going to make a conjecture that it should work out to be the same way, just with some negative signs here at the end instead of positive signs. But let's double check ourselves. So in this case, we have that a times c for that remaining middle term is going to be 12. B is going to be negative 8. So we want to split that middle term into negative 6x minus 2x. And then we're going to drop down absolutely everything else. Now we're going to continue with the factoring by grouping. So between these first two terms, 4x squared and negative 6x, 2x will be their greatest common factor. 4x squared divided by 2x leaves us with 2x. Negative 6x divided by 2x leaves us with minus 3. For these next two terms, we're going to have to pull out a negative 1 because it's negative, but otherwise they're prime. Negative 2x divided by negative 1 leaves us with positive 2x. Positive 3 divided by negative 1 leaves us with negative 3. And then we otherwise still have the 4 parentheses on the outside just chilling. Now for the remaining terms, we have 2x minus 3 in common, so that'll be one of our parentheses. We have 2x minus 1 as the different term, so that'll be the other parentheses. And then we still have the 4 chilling on the outside. You notice how I don't actually have to write larger parentheses there by the associative property of multiplication. Now that this is all multiplication going on, that would just be considered my final answer. I'm going to encourage you to try these next three yourself before we go through them. And in particular, for all three of these, you're going to want to pull out a greatest common factor first. And don't forget that if that leading coefficient is specifically a negative, you want to be sure to pull out a negative first. Now that you've tried these out, let's go ahead and go through them. So for this first one, their greatest common factor is a p. And when I factor out a p, p cubed divided by p leaves us with p squared. Negative 8p squared divided by p leaves us with negative 8p. Negative 20p divided by p leaves us with negative 20. And then we're going to focus on factoring this remaining portion. And this remaining portion, actually, thankfully enough, is that situation where the leading coefficient is 1. So I can go ahead and just directly ask myself, what's going to multiply to c? and add to b. So in this case, it would be negative 10 and positive 2 that would multiply to negative 20 but add to negative 8. And even if you didn't jump straight to the parentheses, let's say you actually did factor that part, the factoring by grouping way, and you split negative 8p into negative 10p plus 2p, drop down the negative 20, drop down the p squared, greatest common factor of each group. Between p squared and 10p, their greatest common factor is p. P squared divided by p is p. Negative 10p divided by p is negative 10. Between 2p and 20, their greatest common factor is 2. 2p divided by p is 2p divided by 2 is p. Negative 20 divided by 2 is negative 10. And then the parenthesis they have the same is p minus 10. What they have different is p plus 2. And oh my gosh, that's exactly identical to the numbers we just came up with before. So that's why we talked about the shortcut way, because when that leading coefficient is 1, you actually can jump straight here and say, hey, that middle part will factor into p minus 10 and p plus 2, since negative 10 times 2 is negative 20, and negative 10 plus 2 is negative 8. But that does work indeed whenever you have a leading coefficient of 1. But if you forget, you always can do that part factoring by grouping as well. For this next one, their greatest common factor is going to be 3m. 3m cubed divided by 3m will leave me with m. Negative 21m squared divided by 3m will leave us with negative 7m. 30m divided by 3m will leave us with plus 10. And then for that, oh, that was 3m squared. I said verbally the square and I forgot to write it down, my bad. And then what would be left is you're going to ask ourselves what's going to multiply to 10 and add to negative 7. That would be negative 5 and negative 2, and that would be your final answer, because in that case we had b is negative 7, c is 10, so negative 5 and negative 2 will add to negative 7 multiplied to 10. For the last one, this has a little bit more of a complex greatest common factor. We're going to want to pull out a negative, because when the leading coefficient is negative, we want to pull out the negative because we're used to that leading coefficient being positive. And then in terms of the x's, it looks like the greatest factor is x to the 4th. And the first one doesn't have a y in it, so we can't consider a y part of the greatest common factor. And then for this one, I'm going to a little bit more explicitly show that division, just because we do have a bit of a longer set of terms this time. 4th y squared over negative 5x to the 4th. So whenever we do that division, negative 5x to the 6th divided by negative 5x to the 4th will leave us with a positive x squared. Positive 10x to the 5th times y divided by negative 5x to the 4th will leave us with a negative 2xy, because 10 divided by negative 5 is negative 2, x to the 5th divided by x to the 4th is x, and then the y divided by 1 is y. Positive 120 divided by negative 5 is going to leave us with negative 24, is that right? 24? I'm actually a little bit paranoid. I'm going to double check that to the side. I'm thinking it is 24, since 120 divided by 10 would be 12, so divided by 5 should be 24. So 5 goes into 12 2 times. 2 times 5 is 10. Subtract that, 20. 5 goes into 20, 24 5 times. So my hypothesis was correct, so that'll be a negative 24. And then in terms of the x's, x to the 4th divided by x to the 4th just is what it is, but then we'll have a y squared there. And then don't get thrown off by the y squared. That part we're just going to still kind of go through the same process that we've been going through. So in particular, when we're focusing in on this center part, what we're wanting to do is multiply to a times c. So in this case, a times c would be a is 1, c is negative 24y squared, so it's really to negative 24y squared. And then b is going to be your negative 2y in terms of what's sort of attached to the x. That's why I would consider b there. So what you're wanting to do is multiply to a times c, so negative 24y squared, and add to b, negative 2y. And I would really focus on the coefficient part of that. So multiply negative 24, add to negative 2. Your numbers should be negative 6 and positive 4. That's going to multiply negative 24 and add to 2. And we're specifically going to stick a y on there, because if I add negative 6y plus 4y, that will give us negative 2y. Negative 6y times 4y will give us a negative 24y squared, since y times y is y squared. And then I believe this is 1 because a is 1. You actually could just jump straight to the parentheses, but just for the sake of argument, let's do this the more factoring by grouping way. So what we're going to do is we're going to break up negative 2xy into what we just came up with. So we kind of have x squared minus 6xy plus 4xy minus 24y squared. So again, I broke up that middle term into those two terms we just came up with. Negative 6xy plus 4xy does equal that middle term still, so we haven't changed the value of the problem. If I then do the factoring by grouping, between x squared and negative 6xy, their greatest common factor is x. X squared divided by x is x. Negative 6xy divided by x is negative 6y. For the next set of terms, 4xy and negative 24y squared, their greatest common factor is 4y. 4xy divided by 4y leaves us with x. Negative 24y squared divided by 4y leaves us with 6y. And now, indeed, we have one parenthesis that's the same, so that's x minus 6y. We will talk about the numbers in front of the parentheses, which are different, which is x plus 4y. And then we're also going to drop down our negative 5x to the fourth, and then we will box this in. So this last one was definitely a spicier problem, but the same general concept worked. So long as that middle term, if there's an extra coefficient or an extra variable on there, that squared still gives you that extra variable that's on the end. If you basically treat it as though it's part of your coefficient, then you can still factor it by the methods that you've been doing. Most problems will look like the problems that we looked at previously, where there's just a single variable, but keep in mind that the general factoring techniques do still apply even if there is more than one variable there. And just to recap, if a is equal to 1, you're going to just ask ourselves what's going to multiply to c, so the last number, but add to b, so the middle coefficient, and then you can jump straight to those numbers you come up with being what is being added or subtracted to your variable in parentheses. Versus if that leading coefficient is not 1, or if you just want to play it safe and always treat it that way, if that leading coefficient is not 1 or no matter what, then you can go through the process of asking yourself what multiplies to a times c and adds to b, split the middle term into those two terms, and then factor by grouping from there.